Hello, we are Aynur Jabiyeva and Gulnara Isgandarova from Azerbaijan State Oil and Industry University. Our article devices for automatic control of the quantity and the quality of the oil in the reservoirs. Currently, the most widely used devices for measuring in the level is liquid, fluid and non-fluid float gauges are generally more accuracy than non-float gauges. However, the operating condition of the float level gauges are much more difficult due to the difficult operating condition of the float in the aggressive environment with the large amount of the mechanical impurities. Mathematical tools are used to measure the weight of the oil, and oil products should provide output information in the form convention for future processing. At the same time, the devices should be structurally simple and applicable to exist types of tanks. The measurement accuracy achieved by the fact that the inter-measurement level is divided into separate equal sections that's determined among other factors by the length each sectors. The devices consist of the reserve and 5-digit drum counter that count the liquid level in the tank. The block diagram of the capacity B level gauge is shown in the figure 1. The measurement accuracy is achieved by the fact that inter-measurement level is divided into separate equal sections is determined among other factors by the length of each section. The devices consist of the reserved and 5-digit drum counter that count the liquid level in the tank. The block diagram of the capacitively level gauge is shown in the figure 1. It consists of the block of described sensor 1, distribution block 2, communication line 3, measurement block 4, control and registration block 5, and power supply 6. The design of the sensor allows them to be attached to the fitting of the oil gauge glasses of the operated tank. The sensors are pieces of two pipes of different diameters located coaxically and isolated from each other by insulation washers. Sensors are grouped of the common pipe. As noted above, during the measurement process, pulses are sent to dynamic errors from the system of described course and the continuous 5 composition by the corresponding sensor. These pulses are fed to dynamic error to the continuous devices of the secondary device, and the continuous result is not on the electroluminescence display. The block diagram of the secondary device is shown in the figure 2. Result. The article also deals with the discharge of the sensor transducer from measuring various non-electrical quantities, as well as methods and devices for obtaining and processing measurement information. The use of devices allows you to automate the process of pumping oil and the most important technological parameters, the dynamic level, which is especially important for marginal wells. In the experience, electrical automatic control devices are variantly of design, and schemes of the measurement instruments were developed and applied. Depth parameter of the well reserved as a technological parameter of the drilling process and the geometrical parameters of the wells. I obtained the greatest possibilities for controlling deep parameters during electrical drilling, since the power channel connections the deep-seated electric motor with surface equipment is at the same time reliable communication channel for the telemetry of the deep parameters. In the technological parameters of the electrical drilling process, we obtained the pressure of the tool on the bottom hole, turgid voltage of the downhole electrical motors, the temperature of the clay solution, the temperature of the bottom hole, etc. In this regard, during electrical drilling, it's possible to control control a complex of technological and geometrical parameters of the drilling process and at the same time perform geophysical surveys of the wells. Thank you for attention.